So I thought I'd do a little video now all about the Riemann zeta function and minus a twelfth and this piece of bullshit in mathematics which has been propagated down the centuries. And it's just because it really, really annoys me. And many years ago now, I attempted a disproof of this idea that the infinite series of 1 plus 2 plus 3 plus 4, etc., going all the way to infinity is equal to minus a twelfth. And I take a huge amount of, well, I get very annoyed when I see people doing like weighting functions and things like this to try and demonstrate that it's equal to minus a twelfth, where it's not equal to a fraction, it's not equal to a negative number, most certainly not. It is equal to infinity, obviously. It must be equal to infinity. And I thought I'd do this video now because this is actually a problem that would yield to empiricism. This is a problem that we can actually test for, unlike so many things in maths. This is something where we can apply, for instance, computers to do the calculations for us. We can take the first series we would take is 1 plus 2 is equal to 3, then 1 plus 2 plus 3 is equal to 6, then 1 plus 2 plus 3 plus 4 is equal to 10, and so on and so forth. And then you can go through these finite series, and see if the finite series converge on anything like a fraction or a negative number. And they don't, of course. They, of course, converge on increasingly large numbers as you go up the different series, 1 plus 2 plus 3 plus 4 plus 5, etc. That's equal to 15, I think. And yeah, and then to do the rest and so on to infinity. And you can use computers to calculate it. So the numbers will just get increasingly big as you get towards infinity. You'll never reach infinity, obviously, because it's just a concept. It's not really a number as such. And the series won't converge on any negative value, most certainly not. They won't converge on any fraction, certainly not. They'll converge on whole positive numbers going all the way up to infinity. And this is a problem that does yield to empiricism. We can test for it. We can just get our most powerful computers to run these calculations until forever, if you like. You can carry this on forever, and we can gain increasingly large degrees of certainty that the series won't converge. It doesn't converge on anything but infinity. And the reason we have infinity as a concept is for exactly this sort of reason. When series in maths don't converge on any kind of value, particularly, it's not going to converge on a whole positive number. Even it's just going to keep going to infinity. So we can sort of prove it that way or disprove this erroneous notion that it's equal to minus a twelfth. And if you go through the mathematics that they try to employ to prove that it's minus a twelfth, you'll find that it's kind of slipshod. It's really sophistry. It's like mathematized casuistry, and using increasingly more complex notions such as zeta function regularization and all this sort of thing, just to get around the very obvious point, the obvious truth, really. And this is very important because it is the truth that we're talking about. The truth is what's at stake. And the truth is that it doesn't converge on a negative fraction. It doesn't converge on anything. It converges on infinity, if you like. You can say that. Um, but yeah, I mean, this is something we can test for now in the age of supercomputers and so on. Fine, back in the days of Euler and Riemann and so on, those didn't have computers at their disposal. They had various ways of dealing with very large numbers, such as multiplication tables and things such as this. But yeah, we live in an age now where our mathematics can be streamlined with the assistance of computer technology, and we don't need to be in this quagmire of illusion that's been passed down through the centuries by great mathematicians. And we can look past their greatness, right, and stop making sacred cows out of these figures and start applying our own rationality to these problems. And we'll find, I think, pretty quickly that nothing is going to converge on a negative fraction. Perhaps if you use a weighting function and just change the infinite series, which is what you're doing when you're adding in a weighting function, you can have it then. But still, minus a 12 is a load of bullshit. I'm sorry to say. And yes, we can test for it. And yes, we can disprove it pretty easily with computers.